In today's class, I'll be talking about the standard deviation. So, what is standard deviation and why we use it? First of all, so standard deviation helps us in figuring out how dispersed the data is from the mean point. So, there is a graph which we will talk about in detail later on, which is called a normal distribution graph, which, as I said, I'm going to talk about in the next lecture. So, this middle line is called mean, and standard deviation helps us how much data is dispersed away from this mean line. That's what standard deviation helps us in figuring out. Now, how to calculate the standard deviation? Standard deviation can be calculated by using a formula that is equal to sigma square equal to sum of x minus mu square divided by n, and then square root of sigma square is standard deviation. This sigma square is called variance, okay, which is square of standard deviation. When I take the square root of this, that's going to give me standard deviation. So you can put it this way also. If I wanted to write directly standard deviation, then sigma will be equal to square root of this term. That's how you can also write it. Now, this is a standard deviation of population. Then to calculate the standard deviation of the sample, the symbol is S. S value will be equal to sum of x minus x bar square divided by n minus 1 and square root of this. This is the standard deviation of a sample. All right, what is the difference between population and sample? I talked about in my previous video. So if you want to see that, and if you don't know about what is the difference, please go and watch that video. All right, now I'm going to take an example and try to calculate the standard deviation. So let's say if I'm given some data points, the data points are 1, 5, 4, 2, 6, 2, 1, 1, 5, 3. These are the data points given to me. And I wanted to calculate the standard deviation for these data points. And this, I'm going to assume this one as a sample, not the population. So I will put them in the order, just in the column direction. So 1, 5, 4, 2, 6, 2, 1, 1, 5, 3. All right. Okay, let me reduce the size so that I can actually see, and this is not right. So I'm going to put them properly in the vertical order. 5, 4, 2, 6, 2, 1, 1, 5, 3. Perfect. Now, in the step 2, I wanted to calculate the standard deviation of the sample. I wanted to calculate x minus x bar. So these are my data points, which are called x also. Now, how can I calculate the x bar? I did it in the previous video also. So add all the data points, add all these data points, and then divide by the number of data points. So that will be equal to 1 plus 5, 1 plus 5 plus 4 plus 2 plus 6 plus 2 plus 1 plus 1 plus 5 plus 3. So divided by number of data points is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 you will divide it by. So 5 plus 1, 6, 6 plus 4 is 10, 10 plus 2 is 12, 12 plus 6 is 18, 18 plus 2 is 20, 21, 22, 22 plus 8 is 30. So 30 divided by 10. So x bar value will come out to be 3. So x bar is 3. Now here I wanted to calculate x minus x bar. So x minus x bar, for that I will draw a line here, and then I will calculate x minus x bar. x minus x bar. That's what I'm gonna try and calculate. So how can I calculate that? 1 minus 3, and then I have to square it to. I'll put a I'll put a square also here. 1 minus 5 square, and then 4 minus 5 square, and then 2 minus, well, I don't know why I took the 5 here. It should be 3. 3 here, 3 here, 3 square, then 6 minus 3 square, 2 minus 3 square, 1 minus 3 square, 1 minus 3 square, 5 minus 3 square, 3 minus 3 square. If I calculate these numbers, this will be 1 minus 3 is 2, 2 square is 4, this is again 4, 4 minus 3 is 1, 1 square is 1, 2, this is 1, because negative 1 square is positive 1. And this squaring will always give you a positive number of these. So you don't need to worry about the negative sign. 6 minus 3 is 3, 9, this is 1, this is 4, this will be 4, this will be this is going to come out to be again 4, this will be 0. And now what does the formula says? I need to take the sum of these values. So if I take the sum of these values, that will be equal to 32. 32. Let's do it. 4 plus 4 is 8 plus 9, 9, 10, 19, 20, 24, 28, 32. So yes, this is 32. Now in the next step, what I'm going to do is I'm going to put them in this formula and get the answer. So uh, this value comes out to be 32 square root of 32, because this value, as I calculated here, should square it sum. Okay, so this is what we've just calculated, and this is 32. N value is, number of term is 10 minus 1. So 10 minus 1 is 9. 32 divided by 9. So I need to do that math. 32 divided by 9. That's going to give me 3.55 repeating. So 3.56 I will call it. And then I will square root this number. So second function square root of 3.56, that's going to come out to be 1.88, or I can say it 1.9, which is equal to standard deviation value. Standard deviation value, well, I should not write it as sigma, I should write it as S, because this is for a sample. So hopefully you were able to understand how we can calculate the standard deviation for a given data. And this is the formula we're going to use. There is another formula given to you in your formula booklet. You don't need to use that formula. You can always use this particular formula. And yeah, well, yes, there is one more, which is a frequency formula, which I'll talk about later on. Let me just quickly show you that formula also. The other formula is sigma square, or sigma equal to square root of frequency frequency times x minus mu square divided by n. This formula you're going to use when you are given the data in the table form. Here the data was given to you in the raw form, and then whenever the data is given to you just in a raw form, then you're going to use this formula. Whenever data is given in the table form, then we're going to use this formula. Means you are given the frequency. So for example, here this data was given to me. I'm going to convert it into table form. I'm going to rewrite this data here, down here. Let me just make some space. So the data given to me was 1 5 4 2 6 2 1 1 5 3. So these were the data points given to me, and this is the raw data. Now If it is in the table form, how it will be presented? It will be presented like this. So one is repeating itself how many times? 1, 2, 3. So frequency here. So this is x, this is frequency. Then well, I will also write the 2. 2 is repeating itself how many times? 1, 2, 2 times. And then 3 is repeating itself how many times? 3 is repeating itself one time. 4 is repeating itself how many times? 4 is only one time. 5 is repeating itself how many times? 5 is two times. And 6 is repeating itself how many times? 6 is repeating itself one time. So how many data points? Sum of frequencies. Sum of frequency is also called the n value, number of data points. 3 plus 2 is 5, plus 1 6, 7, 8, 9, 10. So 10 data points. If I sum up these numbers, that's also 10 data points. Now coming back to the formulas, if you are given if you are given the data in the frequency form, like the table form, then you will use this formula. If you are given the data in just like this format, in this format, then you can get away with using this particular formula. And if these two formulas are given to you in your formula booklet, if any of these formula is not given to you in your formula booklet, you can write it down on your formula booklet too. Okay, these both these formulas, if they are not given to you on your formula booklet. All right, now I'm gonna try and solve this question using the uh, table form also. So this is this is the data given to me, as I said, in the table form. And mean value, I'm going to take it from the previous question. Mean value came out to be 10. Again, you can calculate the mean value from the frequency also. I've solved it in the previous video lecture. I'm not going to solve it here, but I'll just quickly write down the formula which you're going to use to solve this. So x bar value will be like this: frequency times x divided by n. N is the number of data points, which is 10. Sum of frequency 2 can be called as. So x bar value will come out to be 10 if you're going to do this. Now, now I'm gonna try and calculate the standard deviation from here. So to calculate the standard deviation, first of all, I will look at the formula. The formula is sigma, or S I'm using. So here, if I end up using the sigma, let me quickly go back and check. Yeah, this is for population. This is for population. If it is sample, then the formula will become same formula: f x minus mu square n minus 1. This is for sample when the data is in the frequency form. This is for population. This is for sample. Same way as there was for population, this one was for sample. All right, let's go back to the question we were doing. And sum of frequency x minus mu square and divided by, well, here it should be, because it's a sample, x bar divided by n minus 1 and square root equal to s value. Let me quickly see if I put in the square root here or not. Yes, I put in the square root on both the formulas. Okay, so now what I need to do is I need to calculate, first of all, x minus x bar of this value. So x minus x bar, I can calculate here. X minus x bar, I'm going to erase this formula from here to make some space. You can note down on your notebook also, so that you can keep looking at this formula, how I am getting the value. So x minus x bar means x bar was 3. So this value will become 1 minus 3, and then the next value will be 2 minus 3. I'm using this number. Oops, what happened to the pencil? This number I'm using. Let me sharpen up the pencil a little bit. So 2 minus 3 and then 3 minus 3, 4 minus 3, and then 5 minus 3, and then 6 minus 3, and then I will square it also. Square it. If you're going to go back and look into the formula, there is a square also. Let's look into the formula. Where did I write the formula? See, there was square. I should not have used mu here. I should have used x bar here. Whenever we are using the sample, it is x bar. Okay, the symbol, it's just a change of the symbol. They both are mean. All right. Now I will calculate these values. So these values, whoops, these values, let me just quickly see whether it is being recorded or not. Yes, it is. So this value will come out to be uh, 2 square, which is 4. This is 1 square, which is 1. This is 0. This is 1. This is 2 square is 4. This is 3 square is 9. I got this value. Now I need, next step is to multiply it with the frequency. So because the formula was sigma f x minus x bar square divided by n minus 1 square root. That was the formula. So x minus x bar square times frequency times frequency. So 4 times 3, which is 12. 1 times 2 is 2. 0 times 1 is 0. 1 times 1 is 1. 4 times 2 is 8. 9 times 1 is 9. Now I will add up all these numbers. Why? Because there is a sum here. So 8 plus 9 is 17. 17 plus 1, 18, plus 2, 20, 21. This will become 21. Now 21 divided by n minus 1. How many data points are there? Total is 10 data points. So 10 minus 1 and then square root of that. So square root of 21 upon 9. So 21 divided by, clear, 21 divided by 9, that comes out to be 2.33. And then I just quickly need to look into if I end up making any mistake here, so that because the values should come out to be exactly the same. Well, the answer was 1.9 there. Here the answer is, let me see, 2.3 is the value. If I take square root of this second function, square root of 2.3 I got, which is 1.51. My answer is missing by a little bit. I just quickly need to check in why I am missing, if I'm missing any data point here. So I've taken the 3 here, 3. So these data points looks correct to me. So quickly I'm gonna look at here x minus x bar and frequency n minus 1. Let me just quickly look at down here. How did I get to this number? I got this number as 32 here. 32 upon 9. And why did I got 21 here? That's what I need to look into. I might be making some mistake here. So I think I might have to take, I think yes, I know where I made the mistake, because I was creating a question out of my own mind. So how many data points are 1? This is 3. Let me just quickly see. 1, 2, 3. And then this is 2. 2 is repeating itself twice. And then 3 is repeating itself how many times? 3 is repeating itself 1 time. 4 is repeating itself 1 time. and 5 is repeating itself twice, 6 is repeating itself one time. So x minus x bar was 3, which I am going to cross verify, is it 3 or I am using some other number. So sum is 30. Yes, it was 3. So this is 1 minus 3. 1 minus 3 is uh, 2. 2 square is 4. 2 minus 3 is 1. 1 square. 3 minus 3 is 0. 4 minus 3 is 1. 5 minus 3 is 5 minus 3 is 2. And then 6 minus 1 is 6 minus 3 is 3. 3, 9. And I am missing just a 10 here. So frequency times 4. Okay, I don't know from where I got this number. See, 4 times 3 is 12. And 2 times 1 is 2. Rest everything is right. 1 0 1 1 2 is 8 9. Let's see now. So this is 20, well, 14 14 15 15 plus 8, 15 plus 8, 15 plus 8 plus 9, which is equal to 32. See, just a slight error, and pretty much everything was going wrong. But luckily, we were able to figure it out. So this will become 32, and this will become 32 here also, 32 square root of this number, and then that's going to come out to be approximately 1.9. So same question, I've done it with the table form also. So whatever way you wanted to do it, if I will encourage you, if you are given the question in this format, just use the first formula. If the question is given in this format, then use the second formula. And majority of the questions will be in the sample format. If the question does not say anything, whether it's a sample or a population, just use it as a sample. So hopefully you were able to understand how to calculate the standard deviation. I'll see you with another video. Till then, goodbye.